Hello, Algebra 2 scholars. Skill 3.2 is focused on finding intercepts, like X and Y intercepts. And I know that, that kind of sounds like Algebra 1. Well, you kind of start seeing it in Algebra 1 with linear functions. But when we go to Algebra 2, we may have, things like these quadratics, where you're finding the X and Y intercepts. And then next week, we're going to be actually kind of looking at things like exponential functions, where you'll see like intercepts like that, or towards the end of the session, you're going to see what are called rational functions as well. And guess what? They also sometimes have intercepts too as well. So why not kind of talk about a universal language as to how we can find our x-intercepts and y-intercepts, no matter what type of function it is. So the x-intercept obviously crosses the x-axis. That's what it means for an x-intercept, and that means that it has a y-coordinate of 0. So we could say that x-intercept is going to be x comma 0 in format. And then we could say that the y-intercept is where the graph crosses the y-axis and it has an x-coordinate of 0. So that would be our coordinate of 0 comma y. So make sure you kind of have, those general rules written at the top of your notes and starred, because they are, kind of universal in nature, no matter if you have a straight graph, like a linear, or, something fancy like an exponential or a rational, like what we're going to see next week. We're going to kind of just focus mainly in the sphere of like quadratics and polynomial functions. The first type of questions are just simply like the graphically ones, and the x-intercept of a graph is where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. So if we want to find on the graph, like the x-intercepts, they will be at -3 comma 0 and 5 comma 0. You could also factor that polynomial as well. And then the y-intercept, one thing that you're going to kind of notice here is I have a -15. So that y-intercept is going to actually be at 0 comma -15. And if you notice, there's a -15 as a constant. So that's going to give us our y-intercept in the quadratic. And then sometimes on the SAT, they'll purposely give you something that is not as familiar of a function. But we can kind of see that the x-intercepts in this case are at -3 comma 0, 0 comma 0, also a y-intercept as well, and 1 comma 0, and then our y-intercept is at 0 comma 0. So let's actually look at another type of question here. The delta math example, they may give you alternate terminology. So they might say real solutions. So real solutions just simply means listing out your x-intercepts. So we have solutions at -5, -1, 4, and 8. Let's say that we want to find the y-intercepts analytically using the equations. So what you're going to do with that is you are going to replace all the x values with 0. And sometimes that y could be disguised as f of x as well, kind of like in part C. And then you're just going to plug in 0, which is kind of nice in this because all the 0 terms, do go away. So we can pretty quickly see just by reading the constant of our quadratic that the y-intercept is at 4. We can kind of put it in coordinate form as well. Now in this one, we don't have a y equals, but if you actually just put in 5 times 0 plus 2y equals 8, we just get 2y equals 8. And that means that y is equal to 4. And then this one is just with function notation instead. And then on this one, what they may do on the SAT is give you something like an exponential. But if you kind of got that same idea of like plugging in 0 for your x value, you can actually find out what that y value is going to be as well. And anything that's exponentiated to the 0 is just 1. And we can pretty quickly see that the y-intercept is going to be 3. And we don't even really need to know much about exponential functions to discover that. Let's say we want to find the x-intercepts. We want to replace the y value with 0 and equate. So on this case here, I have 8x equals plus 3 times 0 equals to 4. So that means that x is equal to 4 over 8, or 1/2. And then on this one, I'm just going to set this equal to 0. And when we have things that are factored and set equal to 0, you're going to take each factor and set it equal to 0. And then kind of the same thing on this one as well. So like we have x minus 5 equals 0, x minus 4 equals 0. And x plus 7 equals 0. And then that would get you like all the zeros. And then finally, like here, we have like a table data type of scenario. One thing we can kind of notice here is that when the x is equal to 0, and you could kind of like see this if we were to graph it, 0, 3 would get us that y-intercept. So remember, like when we find an x-intercept, that means that our y is equal to 0. And then when our y-intercept, our x is equal to 0. So our y-intercept would be 0, 3. And then our x-intercept would be 4, 0. And I think that is about it for that. that's kind of your crash course. So make sure, you're kind of paying attention that when you are finding an intercept, you set the other coordinate equal to 0, basically. So for x-intercepts, you set the y equals 0, and for y-intercepts, you set the x equals to 0.